Today we are going to start with the video of DC speed control system or control lab. We will be doing two operations. One is in open loop and another is in closed loop. So first we will check all the parameters which we can observe on a DSO and what parameters can we see on our voltmeter. The first parameter that we can see on the DSO is our waveform for the tacho feedback. So for the RPM measure, in this trainer kit we are using an optical sensor to measure the RPM of our motor, and the tacho feedback can be seen on this point. You can see that the tacho feedback is basically the output waveform of our sensor. Now if I change it, as I change this our speed of the motor, the speed is around 2000. I'll press reset and recheck the RPM. 2373. This is my waveform of the tacho feedback, and the other waveform which we can see is that is on, this is our VS, this is our square waveform. Only to see the waveform properly, we first have to put the probe into 10, because it is a, this CRO will only be able to, this DSO will only be able to capture a waveform of a particular frequency. Now this is our square waveform which we have given on the VS. To measure it properly, you have to put the probe into 10 position. And this is our motor driver output. This will vary as we vary the gain. Then gain is varied from this potentiometer. So first what we have to do is we have to set the reference voltage at 1 volt through this knob. I've set it to 1 volt. Then we have to check our VT, tacho feedback, in open loop. For open loop we have to keep the square wave in the down position. We have to check the tacho feedback for different RPM levels. For that, the first experiment will be to measure the tacho feedback at different RPM levels. For that, first of all, what you have to do is to set gain to 0. Make sure the motor is stopped. As soon as it starts moving and you get a tacho feedback, when you start taking readings from this position till the maximum RPM that you can get. And this is our motor voltage. So this is our open loop operation, and to apply braking, magnetic braking, we will be using this lever. It has a magnet inside, and the magnetic plates apply brakes on the disc through magnetic interference. Now for closed loop operation, we will connect the feedback to so as you can see, we will be showing you the operation of the feedback in closed loop. So the feedback is happening this way, that the actual voltage which is being given to the system is motor is 1.73 volts, right? But as soon as the system is in closed loop and brakes are applied, the system tries to give more voltage to the motor so that it can maintain the previous speed. So this is our closed loop operation, and to get the proper waveform. And then now there's a point for disturbance. This square knob helps us introduce a square wave in the system. This is our taco, and this is our motor feedback. And this is our square wave. Make sure to switch the probe to into 10 for proper reading of the square wave and the motor driver output.